Hey girl, what kind of math you doing there?
Pythagorean.
What's up guys, welcome back. I told you I would be back with another video. So this time we're going to be doing topic 6.2, advanced derivative rules. Lesson summary. So right now I'm just going to tell you what we're going to be talking about in this lesson and what are advanced derivative rules. Basically, advanced derivative rules are shortcuts. That's all they really are. Shortcuts in math that can help you find the derivative of functions way easier. So, in this lesson, we're going to be talking about the chain rule, which is very important in calculus because later on in other units, you're going to be having to anti-differentiate, so anti-chain rule. So it's important that we understand the concept of the chain rule right now. Then we're going to talk about the product rule, then the quotient rule, and then after explaining each rule, I'm going to be doing an example. And then at the end, I'm going to assign you guys an IB problem that you might find on your IB exam that has multiple parts. So one question, so I'll be going over chain rule, product rule, quotient rule with examples for each, assigning a homework at the end, and then providing the answers. So let's get right into it. Chain rule. So I'm going to be explaining the chain rule two ways. One, based on the formula packet and what IB wants you to know, and another way that's just a way simpler and easier method for me to understand that might help you. So the first one is a chain rule, which is here in topic 6.2 under topic 6 calculus. And this is what's going to be in your formula packet during the IB exam. So it's important that we understand what that means. So y is equal to g of u. So g is the outer function. U is the inner function. But u is equal to f of x, which is the actual function that's found inside of the equation. So, in order to find the derivative, you have to multiply the derivative of y by the derivative of u, which is what can be seen in your formula packet. So this represents the derivative, which is notation for the derivative. This is the derivative of y times the derivative of u. And this is the formula that can be found in your formula packet, which I'll show you again in a second, which can be found here, chain rule under topic 6, calculus. Okay, so this is what IB wants you to know. So basically, the chain rule is plugging in, well, all advanced derivative rules is plugging in numbers and functions into G. Okay, so now that we learned about what IB wants us to know and what the formula packet tells us, we're going to learn how to do chain rules simplified. So this is an easier method for me to understand just because there's less letters and it's just way easier to understand for me personally. So if f of x is equal to u v of x, then it has to be true that f prime of x, which is just the derivative, is equal to u prime, the derivative of u, times v of x times v prime of x, which is the derivative of v. In the formula packet, we saw y equals g times u, which was just the outer function times the inner function. that is basically the same thing here, where u is the outer and v of x is the innermost function. So now that we understand the basic concepts of the chain rule, we're going to start by doing an easier example and then go into a more advanced example of the chain rule. So the first problem is y equals sine 3x. So because there's a function inside of a function, we have to do the chain rule. So if we know that, as we learned in the past little slide, f of x is equal to u times v of x. So we know u is the outer, v of x is the inner. So that means that sine is u and 3x is v of x. So we can write that down. U is equal to sine v, or you can put v of x is equal to 3x. So then, if we refer back to the easier equation, the simplified equation that I showed you guys, f prime of x is equal to u prime v prime of x times v prime of x. So we have to find the derivative of u and v so that we can plug it back into the simplified equation. So u prime, the derivative of sine, if we look and refer back to our formula packets, in 6.2, the derivative of sine is cosine. So just put cosine here, and it's important to be organized so that you know what to plug in. And once you gain more practice, then you won't have to do all of this. But for right now, we should. So now, to find v prime of x, which is the derivative of v, we just have to get rid of the x, and v prime will be 3. So now that we have all of these, so now that we have all these values, we can plug them back into the simplified chain rule equation. So f prime of x is equal to cosine times 3 of x times 3. So then this would just be 3 cosine 3x. And that's the derivative of y equals sine 3x. Okay, so now we're going to move on to the next advanced derivative rule, which is the product rule. So as you know, a product is when you multiply one thing with another. So same thing in this case, you're multiplying u times v. So right now we're going with the formula packet definition once again. So it says if y is equal to u of x times v of x, then dy over dx, which is just the derivative, is equal to du over dx times v plus u dv over dx, where this is just the derivative of u, and this is the derivative of v. So in order to find the derivative, you multiply the derivative of u times v plus the derivative of v times u. So now we're going to go with the simplified version once again. So when it's simplified, y equals u times v. So y prime is equal to v times u prime plus u times v1. And although remember that we have this equation, it's also important that we understand what the equation inside of the formula packet means. Okay, so on top of this, other people enjoy the h of x's and the f of x's and the g of x's, so we could also write this as h of x is equal to f of x times g of x, And then this equation, which is just the same one in the formula packet, would then be h prime of x is equal to g of x, f times f prime of x, plus f of x times g prime of x. Okay, now we're going to go right in and do an example of the product rule. So it says, differentiate y equals x to the fourth 3x squared minus 5 to the fifth power. And it says to factor our answer. So let's write down the product rule over here. F of x is times g of x is equal to f prime of x, g of x, plus f of x, g prime of x. So first, we need to figure out what our inner and outer functions are. So in this case, f of x is going to be x to the fourth here. And g of x is going to be the innermost function, 3x squared minus 5 to the fifth power. Now, we're going to find the derivative of both. So f prime of x is equal to 4x to the third. Once again, using the power rule. So when you bring, to just explain it, when you bring the exponent forward to differentiate, you also have to subtract 1 from the exponent. So it's 4x to the third. And then we're going to differentiate this. And it's going to be 30x times 3x squared minus 5 to the fourth power. So then now we're going to plug all the values that we got back into this equation. So f of x times g of x is equal to 4x to the third, 3x squared minus 5 to the fifth power, plus x to the fourth, 30x times 3x squared minus 5 to the fourth power. So since it tells us to factor, we need to factor this. So then we find all that's factorable. So we can see it's 2x to the third, 3x squared minus 5 to the fourth. And we can factor out a 2 from here. So then it becomes 2, 3x to the second minus 5 plus 15x squared. And then we can further simplify and make this into 2x to the third. Okay, so then it would be 2x to the third times 3x squared minus 5 to the fourth times 6x squared minus 10 plus 15x squared. So then, once we simplify again, it will end up being 2x to the third, 3x squared minus 5 to the fourth, times 21x squared minus 10. And that's our factorized differentiated equation. And that's the product rule. Next, we're going to be talking about the quotient rule. So, as we know, quotient means division. This is simply the division of u divided by v. So, based on the formula packet, it says if y is equal to u x divided by u times v times x, then the derivative, which is dy over dx, will be equal to the derivative of u times v minus u times the derivative of v over v squared. So this is derivative of u times v, derivative of v times u, all over v squared. The top part, the numerator of this, may seem familiar, but that's because the numerator is the product rule. The only difference is it's being divided by v squared. So, the simplified version of this, so the question is a show that problem. And as a class, we're not very good at show that problems. But we're going to try it because we need it for the IB exam. That's like in 13 days. So like, yeah. Okay, so the question says, show that d over dx tan x is equal to 1 over cosine squared x. So we see that there's a 1 over cosine squared x. So that should immediately, if we see division, we should know that we should do the quotient rule. So let's write down the simplified version here. Y prime is equal to u prime times v minus u times v prime all over v squared. This is the quotient rule. And remember, this rule isn't in your formula booklet. The original one is, so we have to understand what that original one means, and then you can remember this one on the side. Okay, so first, like any other one, we have to figure out what our u and what our v's are. So in this case, our u's is going to be sine x, because tangent is equal to sine over cosine. So our u is sine x, and our v is cosine x. So now we have to find the derivative of these functions. So u prime, v prime. So if we look in our formula packet, the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. So it's very important to refer back to your formula packet so you know if you are differentiating correctly. So now we're just going to plug in our values into the quotient rule. So y prime is equal to cosine x times cosine x minus sine x minus sine x all over cosine x squared. And remember, the argument is squared. So then, once we simplify this, we get cosine squared x plus sine squared x over cosine squared x, which if we look at our identities, our trig identities, then this will all end up being 1 over cosine squared x, which was what we wanted to get, which is correct. Okay, so now that we went over chain rule, product rule, and quotient rule, and someone talked about the power rule, we're now going to do a homework. So in 6.1, we also learned how to write equations of tangents and normals. So that's embedded in this question, but also the chain rule, product rule, you'll have to figure out what to use. So the homework says, which is an IB style question, consider a function where f of x equals the square root of 4x plus 5. The first part says find f prime of 1. Then it says, consider another function g. Let s be a point on graph G where r's x coordinate is 1 and the y coordinate we don't know. So the equation of the tangent is y equals 3x plus 6. So the next parts b and c are find g prime of 1 and find g1. And then d is let h of x equal f of x times g of x. Find equation of tangent to the graph of h at x equals 1. So you can stop the video here, pause it, try out this homework, and the answers will be in the next few seconds. So please pause now. Okay, and here are the answers. Just want to thank you guys so much for bringing me back for another video. Make sure you like and subscribe and comment if you want another video. Today's keyword is I love math. So if you stayed to the end, thank you so much and have a great day. Thank you.